All right, so before we were looking at common logs, now we're going to switch over to natural logs. Now, natural logs are logarithm with a base e. So that's the difference. A common log had base 10. Now we're with natural logs, that's base e. And so we usually write that log base e of x, or more commonly ln of x, because this is what you're going to find on your calculator. Now, the same thing happens with the natural logs. We have to have x greater than 0. So if we take and plug in a negative number or even 0, 0 is not going to work either because it's not greater than or equal to 0. It's greater than 0. So you have to start at like 0.000001 to get it to work. And when we do that, this says y equals ln of x, which is equivalent to e to the y is equal to x. And so to see this, we might have to write it in the form log base e of x. Not necessarily if you can see things different, but to be able to write it and get to this form over here, sometimes you need to see the base e to the y is equal to x. And so that makes it sometimes easier to see for a lot of people to write it with the log base e. Okay. So it's read as the logarithm with base e of x, or more commonly just the natural logarithm of x. So when you see that, that's just the natural log of x. And if you really want to know what happens, a lot of times we'll call that just say the ln of x. And over here, when we see the log of x, and whether it's, whatever form, we'll call that log of x. And this is ln of x, and then we don't ever say common log or natural log. A lot of times we get lazy and we drop those. And so then we have to know that the ln of x is the natural log and the log base 10 is the common log. So it's something you'll have to pay attention to. Mathematicians do it a lot. They just drop it. They just say ln or log, and they go either way. And you just have to remember which one is which. All right, so it's the logarithm y is the exponent to which e must be raised to get our x. So since y equals ln of x is equivalent to x equals e to the y, then our y is equal to ln of x and y equals e to the x are inverse functions again, which we saw before. Okay, and so what we have here is ln of e to the x is equal to x for all x, and e is equal to x for x greater than 0. So what happens here? How do we get that? Well, ln of e to the x is equal to x. Well, what happens is when we have ln of e to the x, we can bring down our x, and we get x ln of e, and that's equal to x. Well, what's ln of e? Well, by definition, ln of e is 1. So x times 1 is equal to x. And so that's how we get x is equal to x. Now, if we want to, we can kind of show you if we take the ln of e. So here's our ln function, ln. Now we have to go second ln and get the e, and it's to the first. Now we have to remember to arrow down, parenthesis, and we'll see that that's equal to 1. And that's why we can go and say ln of e to the x is equal to x. And so that's how it works. When we take ln of e to some power, we just bring that power down in front, ln of e disappears, and we just get whatever that power is. So, if we had ln of e to the 2.9, well, that's just going to be equal to 2.9 because we're going to bring that 2.9 down in front times ln of e. That goes to 1, and we get the 2.9. All right, so this time we're going to use our calculator to calculate the following in rounding to 4 decimal places: the ln of the square root of 2, the ln of 4/5, and the ln of negative 500. What do we say already? X had to be greater than 0, so this one cannot be done, basically, as x has to be greater than 0. So we don't even have to go to our calculator. If you see something where it's saying take the log of a negative, boom, you're done already. And so we don't have to worry about that one. But the other two we can do. All right, so we want the ln, and it said the square root of 2. So now we have to have second square root 2. Now we have to arrow out, parenthesis, and we get 0.34657, and it said to 4 decimal places, so 0.3466. Okay. Then it also said find ln of 4 divided by 5, and then we'll put that in parentheses. And that's a negative 0.2231, and that's as far as it rounds. And so let's write those down. And again, it's just, can you plug into your calculator properly? That's the whole key here. So that was 0.3466, and that one was a negative 0.2231. So nothing hard. Can you plug it into your calculator was the key thing here. All right. So here it says the exposure index, EI, for a 35 millimeter camera is a measurement of the amount of light that hits the film. It is determined by the equation EI equals log base 2 of f squared over t, where f is the f-stop setting on the camera, and t is the exposure time in seconds. Suppose the f-stop setting is 8 and the desired exposure time is 2 seconds. What will be the resulting exposure index? Okay, well, all we have to do is we have to plug in things. So we want the exposure index, and it's log base 2 of, well, they said f is 8, so that's going to be 8 squared over, and time was 2 seconds. Okay. So now 8 squared, that's going to be 64, divided by 2 is 32. So log base 2 of 32. All right, and that's still equal to our EI. So now what can we do? Well, we can say, well, 2 to the EI, so we could probably change it to Y, but we'll just leave it EI, is equal to 32. So now we have to think of, what do we have to raise 2 to get 32? Well, if we remember back to one of the earlier videos, 2 to the 5th is equal to 32. So therefore, EI is equal to 5. And so that's going to be our exposure index if we want that f-stop of 8 and exposure time of 2 seconds. Okay, so if you know a lot about cameras, you'll be able to do this a lot easier in your head. Probably even you just boom, click it, and you'll get your values. But if you don't, this is how you would do it using logs. You'd take, 2 to your EI is equal to 32. And then how do we solve that mentally? Well, 2 to what power is 32? 2 to the 5th. And so our EI is equal to 5. All right, so now we're supposed to refer to the previous exercise. So I'm thinking we want to write this equation down again. So let's do that before we read the rest of the question. So EI is equal to log base 2 of f squared over the t. Now my f's and t's look too much alike here, but that's okay. Now, suppose the light meter on a camera indicates an EI of -2. All right, so now we know this one, so that's a -2. And the desired exposure time is 16 seconds. What should the f-stop be? Aha, so this is more along the lines of what you're going to set your camera with, because you're going to need to set your f-stop, and you're going to have some exposure index that your light meter shows. And so this is going to be just plugging in values. And again, there's probably, if you're doing camera work all the time, you'll know this from the top of your head, and you don't actually have to do any work. All right, so how do we do that? Well, now we're going to say 2 to the -2 is equal to what? F squared over 16. Okay. Now we want F, so how do we get rid of 16? Well, we multiply by 16 over 1. So we're going to multiply by 16 over 1. And so then we get F squared equals, well, what's 2 to the -2 equal to? Well, if we take that to the denominator, that's 1 over 2 squared, which is 1 over 4. So this becomes 16 over 1 times 1 over 4. And 16 divided by 4 is 4. So now we have f squared is equal to 4. Well, we're going to take the square root of both sides to solve that. Now I'm thinking for f-stops, we're not going to have a negative f-stop. We're only going to have positive f-stops. And so f is equal to 2. Now, if we didn't know if we had positive or negative ones, we could do plus or minus, and then this would really be plus or minus 2 for the f-stop. And then you'd have to know a little bit more about photography, so f would actually just be 2 for the f-stop. Okay. Again, more about cameras than I'm going to teach in class, but that's how you would get that one. You just have to use the positive value here. All right, what about this one? So we're back to earthquakes again. It says the intensity levels I of two earthquakes measured on a seismograph can be compared by the formula log of I1 over I2 is equal to M1 minus M2, where M is the magnitude given by the Richter scale. So what we found before, we knew the difference, and that was what was that? The 3.9 or something like that, and we knew that was equal to that magnitude. So in 2009, an earthquake of a magnitude 6.1 hit Hashun, Japan. In March 2011, the same region experienced yet another more devastating earthquake, this time with a magnitude of 9.0. How many times greater was the intensity of the 2011 earthquake? Round to the nearest whole number. All right, well, what we're going to do is we're going to say, well, log of I1 over I2 is equal to, well, now we know the two uh, magnitudes. And I'm going to take M1 as the larger and M2 as the smaller. So I'm going to take 9.0 minus 6.1. And if I do that, that's going to be 6, 7, 8, 2.9. So I have log of I1 over I2 is equal to 2.9. Now what do I have? Well, remember, this is base 10. So if we need to, we can write that as base 10. And we can say 10 to the 2.9 is equal to I1 over I2. Okay. Now what it says is, how many times greater was the intensity of the 2000 earthquake? Was it 2001 earthquake? 2011 earthquake. I can't talk. Well, let's take and see. We called this one the 2011, this one the 2009 because this is the bigger, so the 1 goes with the 1. So I'm looking for I1. And so how do I get rid of I2 here? I'm going to multiply by I2. I'm going to multiply by I2. So I'm going to say I1 is equal to 10 to the 2.9 times I2. Well, 10 to the 2.9, what does that equal to? Well, 10 to the 2.9 is equal to 794.3, so it's 794.328 I2. But then they said round to the nearest whole number. Well, that's going to be I1 is equal to 794 times I2. Okay, so that is what they're looking for. It's kind of a answer with basing it on the second intensity, which we don't know, but it's 794 times the first intensity was that second intensity, even though it's only by years wise, but we're calling the M1 the 2011, M2 the 2009 because we're taking larger minus smaller. All right, and that's all I have for this section. So hope that helps.